In this video, I'd like to talk about the math question of the day for Sunday, May 7th, 2023. And with this problem, we have the integral of this trig function. And since this is a more complicated trig function, the techniques for solving this are typically taught in a Calculus 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And I do want to mention that if this was not raised to the fourth power, if this was to the first power, then we can just use more basic U substitution or integration techniques to actually solve this. But because this is raised to an exponent, it becomes a little bit more complicated, and we need to use our trig identities to simplify this before we can evaluate it. And this is raised to an even power, so we can use the half angle identity to simplify this. So let me paste that in. And the key idea is to recognize that we can rewrite this as the cosine squared of 2t, and then all of that would be squared. So let's rewrite this integral as the cosine squared of 2t, and then all of this is squared. And now that we have the cosine squared of our angle, we can use this half angle identity. So let's substitute that in. We would have the integral of 1 plus the cosine of twice the original angle, so twice 2t, which would be 4t. All of that is then divided by 2, and we still need to square everything. So let's square everything from here, and we are squaring the numerator and denominator, so in the denominator we get 2 squared, or everything is divided by 4, which we can factor out. So we have 1/4 on the outside, then we have the integral, and I will just rewrite it twice, of 1 plus the cosine of 4t multiplied by 1 plus the cosine of 4t, and now we can use distribution, so that the 1's multiply together, we get 1, and then 1 times the cosine of 4t, plus 1 times the cosine of 4t, that's really just 2 times by the cosine of 4t. And the cosine of 4t multiplied by itself would give us the cosine squared of 4t. And let me just make a bit of room so we can finish this. And we have dt. Now, at this point, we will actually need to apply that formula again to this term. Though I should mention these terms right here are simple enough that we can use basic integration techniques or use substitution to actually simplify those. But let's rewrite this using our formula again. I will repaste it. We have that this integral here is 1/4 the integral of 1 plus twice the cosine of 4t plus this expression here, but we will use our half angle identity again, so that we get 1 plus the cosine of twice this angle, 4t, so we have the cosine of 8t, and then all of that is divided by 2, and we still have dt out at the end. And we can simplify everything. Notice we have 1/2, which we can add to this 1 here. That will give us 3/2. Plus twice this cosine of 4t plus the cosine of 8t divided by 2, and we still have dt at the end. So now that everything has been reduced to simpler integrals, we can actually evaluate these now. And since we have a sum, we can split this into 3 separate integrals. So let's do that. We would have 1/4 the integral of 3/2 dt plus 1/4 the integral of 2 times the cosine of 4t, though let's just rewrite that as 1/2 the integral of the cosine of 4t, and we can factor this 2 out so that we get 1/8 the integral of the cosine of 8t dt. I forgot my dt here. Let me clean that up a bit. And for this first integral, we can just use the power rule. The constant can actually factor out so that we get 3/8, and then it's the integral of dt, which we know is just t. we really have t to the 0. We increase the exponent by 1 and then divide by that new exponent so that we just get t. And we will have a constant of integration, but I'll just put that at the end for all of these. We can combine all their constants of integration into one unique constant. And for these, we will need to use a u substitution. For this one, we can set u equal to 4t. We take the derivative of both sides. We get du is 4 dt, or really we can put the 4 over here, so that dt is du over 4. And we can rewrite that integral as 1/2, or really we can factor the 4 out so that it's 1/8, the integral of the cosine of u du. And we'll do something similar here, though let's use a different letter. We can say that v is 8t, so that dv is 8 dt, or dv over 8 is dt. And we can factor that 8 out in the denominator so that we get 64th multiplied by the integral of the cosine of v dv. And like I mentioned, we will have some constant of integration at the end. I will for now just call it c1 since it only comes from this first integral. And let's evaluate these two integrals so that we can combine everything. We have 3/8 t plus this integral, which would be 1/8 multiplied by the sine of u, but u is 4t. And then we have plus 1 over 64 multiplied by this integral, and the integral of the cosine of v is just the sine of v, which v is 8t, so let's put everything back in terms of t. And we have our constant of integration, which now we can just call c, since we can really add these constants from each of these together for just one constant. So this right here will be our final answer. And of course, there are a couple ways to check this. You can just take its derivative and recombine all of the trig functions so that you get back the original function. You can recombine those using the trig identities, or you can use an online integral calculator to let a computer evaluate this for you just to make sure you're on the right track. But the first method of taking the derivative is the one that you should master first before using online calculators to check your work.